tall building like this, there's a lot of plant and equipment that's up very high in the building, which during the life of the building will have to be replaced several times. What strategy do you use for some of the elevated plant, like the air-cooled chiller that's up the top?
Can you repeat once again? Because I missed your first part.
Yeah.
Slowly, because our English standard is not
Yeah. Over the 80-year life of the building, a lot of the plant will need to be replaced. Particularly, there's some chillers, air-cooled chillers up very high in the building. What's the regime for their replacement over the life of the building?
What is the...
How do you replace them?
You've got a packaged air-cooled chiller at the
very
top.
Yeah.
How do you replace that when it breaks?
His English better. His English better. Sorry about that. Your action is John, maybe. You're talking air cool, right?
Yeah.
But actually, normally they use the air cool as a backup only, and they use most of the time to use the water cool system from the center. So the life cycle, the air cool maybe, but still it got replaced in 30, 40 years. Okay? But I think for the if you want to take it up from the roof, it's difficult. So that's why that for all major tall buildings, we'll design a big elevator. Like Shanghai Tower, with huge and it's 3,500 tons. The size of the elevator is almost the size of this table.
Yeah, we on the Shanghai Tower, we
Shanghai
have
Tower,
oversized elevator,
Yeah.
same as Suzhou
Yeah.
Tower. We have 4,000 kg large platform elevator to show.
It is huge because the big elevator has a lot of purpose. They use for delivery of curtain wall, right?
Yeah.
A lot of purpose, and then when we size the chillers, whatever, we try to use the elevator size to such that by most of the time they have to disassemble, but at least it's long enough to come in one piece, and so it's that when you get in the elevator, you're done. It can be anywhere.
In some of the super high-rise building, we might be using BMU system to help to lift big items from the window wall, curtain wall, window washing system, crane.
Yeah, you can use that for some of the facade panels, but you couldn't lift a chiller on a
No,
BMU.
I
think you have asked a very good question on how to, how to remove or relocate some large equipment on top of the tower. Actually, in sizing the air-cooled chillers, we based on the
don't use a big one.
Exactly. Yeah. I think
a few smaller ones.
Yeah. We will base on the most large size surface elevator, which is now is talking about 3,600 ton, and based on that size, we will size back the size of the air-cooled chillers. That's why we will use small air-cooled chillers rather than large air-cooled chillers.
So it could be a group of smaller chillers to suit the elevator.
Exactly.
Yeah.
Not just one large talking about 300 ton, then that is nonsense. In particular, for those tall building projects, you need to think about how to locate or how to remove some large equipment. For example, chillers, even the glass panels or transformers, something like that. Then you, based on the size of the large surface elevator, then you can work back what is the bigger size of the MEP equipment.
A good example, you look at Empire State. Nothing can be moved from the building because the window is only that size.
Yeah.
You can only remove anything smaller than the window.
We've just had something similar in London on the Canary Wharf building. I know our buildings are half the size of yours, but on the Canary Wharf building they just had to change the cooling towers and they had to cut them up into pieces and then have special ones built and taken up, and they wish they'd made them of stainless steel and they would have just had to change the components within them. So it's coming around in a circle.
Yeah. That's a good question. How to locate those large equipment and how to remove out that.
Yeah, it's a big issue in a lot of buildings that aren't built with that plan, and it's a big problem.
So I saw really good shaft arrangement. We stacked local groups. Seems really very slim. But you mentioned that you worked with calculating the interval times.
Mm-hmm.
Did you also work with simulation programs and did traffic flow simulation to the elevators or just calculating what the elevator system is doing? It's a round trip.
We did not do a comprehensive overall simulation. We only do computerized modeling by our elevator consultant, by each group of elevator, by the function and the area. So all this were put into the computers as proprietary elevator programming system that's being used to calculate.
Calculate, not simulate.
Not simulate. It's
Because
a computer software to calculate rather than simulation.
Okay. Because it's my concern is always when somebody speaks about interval time, that the relation to the waiting time of the people is really lost. Yes. At the end of the time, the interval tells you only how often the elevator will leave in front of you, but you cannot enter because it's already full. So this is therefore I prefer always working with simulation.
Elevator people, because every interval is related to every waiting time.
As soon as you have queuing, it will the relation to waiting time is lost.
The program that they use also includes the so-called car fill factor, which we normally, depending on the type of occupancy and the time of day. As an example, office we normally use 80-85% car fill factor. By putting those information into the computer program, it would help us to determine how many elevator will be used or needs in order to service all these occupants and to meet the interval period.
Yeah.
But if you look at apartment, although we have the interval right, but the car fill factor could only be 8%. Because really there aren't that many people using the elevator at the same time. The office is the one that's rather critical in terms of car fill factor.
Yes.
Did you look at destination dispatch for the building as an option?
Yes, and we do, or we will incorporate the destination control system to the office, and we're even thinking of using that for the hotel.
Especially when you work with destination dispatch, there is no interval. So there is you only can simulate. So I just would like to be careful with just working with
We do use the elevator vendor to help us to determine, in addition to the computer modeling.
I understand. There was a second question. You use these elevators for evacuation.
Right.
We also did some simulation for evacuation for buildings in France. And we found that when you have very effective machines and drives, switch generated drives, so this means the elevator produces power when it works full, a little bit down, or empty in up direction, and this is always we have this during evacuation because the cars will be full down, you produce energy. This means there is probably more energy produced by the elevators as your diesel generator can. This means we can damage or switch off the diesel in case you make the evacuation during this time. So there should be made a statistic of energy or energy balance to see if probably the elevators have too much energy in the system during diesel operation.
Right. And in our spec, elevator spec, we incorporate the regeneration of the energy.
Yes.
But each vendor has their own system. They generate energy differently. So the spec specify the requirement, but whoever get the project will eventually have to work with us to design with PP the engineers.
Because we had in this project then found out that we have to reduce the speed during evacuation because we produce too much energy. Or we had to work then to switch over to braking resistors and burn it down, which made a next problem because the heat was 4 times higher than in normal operation in the machine rooms.
Yep, we understand that.